So hello everyone, thank you for joining us today. In today's workshop, we're talking all about TypeScript. TypeScript offers all the features of JavaScript plus the additional layer of the type system. In this workshop, you will be introduced to the TypeScript language, why is it created, and learn how you can use it for JavaScript development. You'll also set up the development environment with Visual Studio Code and create your own first TypeScript project. And then you will learn all about the available data types and how you can associate them with different variables. So you will leave this workshop with a good understanding of TypeScript and how you can write simple programs. As you know, the reactors are hubs for founders and developers where they can connect, meet, learn from experts and from the open source community. All about technology. And in today's session, we're having Alan Sanders, who is a senior cloud architect with over 25 years of experience in software engineering and architecture. He will be taking us through this journey and through this workshop, learning all about TypeScript. I'll be here in the background helping out as well. And if you have any question, please send it through. I am based in Abu Dhabi. This is Hussam for the Reactor Abu Dhabi, and excited to have you joining us from different parts of the world. By default, the meeting audio, I would say, will be not enabled, but in case you have any questions, maybe towards the end and you prefer to speak them, I just like message also in the chat and I will enable that for you so that you can ask the question. Otherwise, you can type through and send questions during the session. And a quick reminder about the code of conduct here. We're all coming from different places and backgrounds across the region. So let's keep this environment friendly and welcoming for all. We're all here to learn. So let's be mindful of the each other. And I think that's all. I would love to hand over to Alan to start today's workshop.
Thanks very much, Hussam. Hello, everyone, and welcome to this session on getting started with TypeScript. Let me share my screen. And we will look to go ahead and get rolling. So as, pardon me, as Hussam said, this is an opportunity for us to meet and connect. And as we proceed through this, and you have questions or if you have any issues that come up, anything that you'd like to ask about, please leverage that chat area. And if they are sort of right in the context of what we're covering right now, we may go ahead and address them immediately. If it's something that's maybe going to be covered a little bit in the future or a little bit ahead of time, then we'll maybe say, hey, let's just hold off on that. But I like to try to make this as interactive as it can be, given that we're all over the world and we're doing this remotely. So I want you to feel like you can ask your questions if something comes up and as we proceed through this material. Pardon me. All right, so let's go ahead and get started. So Hussam mentioned the reactors. I think the reactors are a great thing. What are they, right? It's an opportunity for us as community members to come together and learn together, learn from one another, help one another sort of stay ahead of the technological curve, if you will, right? One of the cool things about this industry is there's always a new challenge. There's always something new to learn. Something like the reactors gives us a chance to come together and learn from one another and sort of gives us that additional assistance to kind of stay ahead of the change maybe. So great to have you here. It's a true pleasure and honor for me to be here with you. Hussam mentioned, the fact that we have these available all over the world. So I'm hoping there's a time when we get a chance to meet in person again. I think that's coming. But until such time, right, these types of virtual sessions allow us to connect. I'm currently in Columbus, Ohio. So these types of sessions allow us to connect all over the world. Hussam mentioned the code of conduct, and it's pretty common sense, right? We just want to make sure that we are being kind to one another, respectful, and, creating an environment that supports learning, right? Learning requires patience, requires patience with yourself, requires patience with others. So let's really take the opportunity to exercise that patience with one another and, make this an effective opportunity to kind of learn and grow into these technologies. So enough said about that. Let's go ahead and get right into what we're going to be talking about, right? We're going to be talking about TypeScript. We're going to be talking about what TypeScript is. We're going to be talking about how to sort of get it set up on your environment for development. We're going to talk then also about sort of types in TypeScript, right? The types that put the type in TypeScript, right? We're going to be getting into some of that, talking through what we have available to us in terms of language constructs. And then we're going to talk about how that sort of gets translated or transpiled into JavaScript, right? Ultimately, what we're ending up with is JavaScript because that's what our browser understands, right? But TypeScript gives us the ability to code and from a developer experience, leverage static type checking, compile time checks, IntelliSense, squigglies when we feel like we've done something that maybe we shouldn't have, right? Or if we have something that might cause us issues, it helps us keep our code clean. And then TypeScript is able to transpile that into very, very clean JavaScript. So it really helps in terms of maintainability and then just kind of bringing some of that static type checking to a language like JavaScript. Okay. So you heard about me. I'm Alan Sanders. Been doing this for a long time. Have had a chance to experience a few things. And out of all those things that Hussam mentioned, the one thing that I'm really most interested in, knowing is that I'm passionate about learning. I'm passionate about my own learning. I'm passionate about others learning as well. And that's why I do this. So it's great to have you here. And I'm really excited for this session. I'm hoping you get a lot of great stuff out of this. So here's our agenda. This is what we're going to be trying to cover. We got a lot to cover, right, in 60 minutes. So we'll try to move at a reasonable pace. We'll see sort of how we end up. But what are we going to be talking about, right? We're going to be talking about what is TypeScript, right? What is it? We're going to be talking about how to set up the development environment. And what does it look like to compile TypeScript files? What about setting up a TypeScript project or a set of files within Visual Studio Code? And then we're going to drill into, kind of more information about TypeScript itself and the syntax, right? What types of types are available to us, right? What are the primitive types? There are things like an enum, any, and unknown type, which can be very, very beneficial. And we'll talk about ways that we might use that. Union, intersection, and literal types, collection types. And then depending on where we land with time, we may have a knowledge check and maybe just sort of a summary check-in at the end. As Hussam mentioned, there is a check-in link. Please definitely check in there. There are provided links to multiple areas that we're going to be covering off on today. And one of the things that's going to be included in that set of materials is a link to the GitHub repo where I've posted my slides. Okay, so you can have that available to you. That once we walk through this now during this 60 minutes, taking the opportunity to maybe walk back through it again after the fact can be very, very beneficial. And so having those slides, I'm hoping will be of great benefit to you. Okay, so let's see. I'd like to hear about TypeScript in regular VS rather than VS Code. We'll get into that a little bit. We'll talk a little bit about that. And what Visual Studio provides us in terms of interaction integration with TypeScript. You're going to be able to do TypeScript in Visual Studio. The reason we use Visual Studio Code is because it's a little lighter weight. So we're going to talk a little bit about that, and then we'll talk some about how TypeScript can be leveraged in sort of the full-blown Visual Studio as well. So great question, great call out. We'll kind of talk through some of that as we proceed. Okay. So what is TypeScript? There are a couple of links here to some Microsoft Learn modules, which is really what we're going to be kind of walking through, right? Microsoft Learn is a great platform, in my opinion. There are a ton of modules available for a ton of different technologies. And one of the things I like about the Microsoft Learn platform is it combines, documentation, information, reading, links, with hands-on exercises that you can execute at the same time to help reinforce that learning. Now, we're not going to be reading through these, right? Because you can do that yourself. And I would recommend you do that after the fact for sure. But, you know, we are going to be using these as a way to kind of drive our discussion today. Yair, you had a question? I saw a raised hand. If you have a question, feel free to type it into the chat, right? Definitely. I'm got two screens going. So as I'm, no problem at all. I've got two screens going as I'm presenting material on one, I'm able to sort of monitor the questions on the other. So, you know, let's go ahead. I'm going to open these two links. Let me increase the size. Okay, so we're really going to be going through two different sort of modules, right? One is kind of getting started, and the other one drills a little bit further into types. And you can kind of see that sort of represented in the agenda that I just talked about. All right, can you share the links in the chat box? Sure. Again, make sure that you check in if you haven't had a chance to do that yet, because these links, along with many others, are going to be available for your utilization after the fact. So I'm posting those two links right now. All right, so let's go ahead and dig in. What is TypeScript? Okay, well, TypeScript is an open source language developed by Microsoft. And really, TypeScript represents a superset of JavaScript. Okay, so TypeScript is JavaScript. We can execute this. But the interesting thing here, right, is that with TypeScript, we're able to bring types and static type checking to our JavaScript. JavaScript is dynamically typed, right? So if you're writing your code in JavaScript, you create a variable, you assign it a value, and then you assign it a value of a different type. That's, you know, allowed. Sometimes, though, it would be nice from a sort of conceptual perspective and in terms of organization, it would be nice to be able to sort of enforce types, or at least indicate types in our JavaScript code, right? And then leverage a lot of different features of maybe, you know, other object-oriented languages that we're used to utilizing, having those available to us within our JavaScript coding. And so TypeScript is a platform that allows us to utilize that within our coding, and then it gets transpiled or transformed, translated into clean JavaScript for execution. TypeScript leverages something called type hints, which are really ways for us to, you know, apply a data type, if you will, to a given variable. And then by doing so, at compile time, enforcing the type of information that that variable can hold. We'll kind of dig into that a little bit as we go. I think one of the cool things about TypeScript is it helps to improve readability. You can very clearly and quickly see as you read through TypeScript code where data types are involved, what data types are you know, considered part of the execution. And I think it helps in terms of just error checking and readability. And then the other thing that's interesting with TypeScript is it does support inference, type inference. So if I don't specify a type, but I initialize a variable, TypeScript is able to infer from the value I assign what data type is intended. And then if I attempt to assign a different type value to that variable, it will, you know, raise a compile time error. It will indicate that there's a problem, right? So that can be beneficial as well. You get the inference, right, that you would maybe expect with a dynamic language with some static type checking. And we see that same kind of concept in languages like Go, for example, if you've ever had any experience doing that. All right. Some additional features that we're not, unfortunately, we're not going to have an opportunity to dig deeper into in this obviously shortened 60 minutes that we have. But here are some of the additional things that are available, right? Interfaces, namespaces, generics. We got abstract classes, a lot of function overloading, right? A lot of things that we really find useful and that we take advantage of in other languages. We have that available within JavaScript now through TypeScript as a wrapper, if you will. Next week, there's going to be a session on interfaces in TypeScript. So if you found this one interesting and you're looking to continue to kind of build out your knowledge on TypeScript, definitely join us next week for the session on interfaces, where we'll have a chance to kind of dig a little deeper into that particular aspect of TypeScript. So what we're really looking to do today is kind of build that foundation of what TypeScript is, look at types, and then kind of provide a launching point that we can sort of then build from going forward. All right, I see there's some information in the chat relative to people accessing. Hussam, thank you so much for taking care of that, making sure everybody has access to the information they need. Again, any questions or comments as we proceed, definitely leverage that. Okay. So TypeScript and Java. So TypeScript is fully compatible with JavaScript, right? It is a strict superset. But the key to understand here is that browsers understand JavaScript, right? Browsers don't understand TypeScript. So in order for us to execute or exercise that JavaScript, and could be that we're exercising it via Node, right, on the server side. Or it could be that we are embedding that JavaScript into an HTML page and we want to leverage that in the browser. TypeScript is not, going to cut it, if you would, in that case, right? For execution, that code needs to be JavaScript, right? So in this way, we get kind of the best of both worlds. In TypeScript, we're able to leverage these, key features relative to, static typing, static type checking, and then it gets transpiled or translated into clean JavaScript code that can be leveraged within our browser or our Node environment. We had a question that came in, how about a superset of browsers too, so that we will not need transpilers? That is, that's, I had someone else ask, I did a session of this yesterday as well, and someone asked about, are there going to be, are we aware of any efforts to kind of take things that are within TypeScript and kind of pull them into sort of mainstream JavaScript, so then it just becomes a part of that language going forward? I'm not aware of anything. There may be something in the works there in terms of a new version of JavaScript that would include that or provide that. But I know it's kind of an interesting thing, right? We have this layer of transpilation that sits in between, something that we have to sort of deal with right now. But who knows, in the future, that may be different. There may be more of just sort of a direct access to TypeScript within the browser versus going through transpilation. Okay, so let's talk about the development environment. Okay, what does it look like to do TypeScript development? Well, we have a couple of options. One option is the TypeScript Playground. And I don't know if you've ever had a chance to deal with that, but let me just open that up real quick. So if I flip over here and I go to typescriptlang.org/play, that will bring me into a browser window. Let me make this a little bigger. That will bring me into a window that shows TypeScript on the left and then shows a few different things on the right. It shows what that TypeScript is actually going to get transpiled into relative to JavaScript. It might show you some errors. It might show you the result of console.logs that we are executing here. And, with the Playground, you're not really going to build an application, right, and deploy an application from the Playground. But the Playground is a great place to try something, right, to sort of familiarize yourself with the concept. If you just want to check something quickly, sort of a particular concept or piece of syntax of TypeScript, you can do that in the Playground and sort of get a sense for what that's going to look like, how that's going to operate before maybe implementing it or integrating it into your development environment, whether it be VS Code or Visual Studio. So if I, on the left-hand side here, let me add a new function, which is fairly simplistic. Let me call that function. Okay, pretty straightforward, standard JavaScript. We have a function, takes two parameters, an X and a Y, and it returns their sum. And then we're going to do a console.log to execute or call that. What we see here is the TypeScript on the left, the JavaScript on the right. Really not much, really the only difference is this addition of use strict. We are showing a couple of errors, which I'll talk about in just a sec. But if I run this, I'm going to get pretty much what I expect, right? A console.log is going to show me 7. So what's the benefit of TypeScript? Well, the benefit of TypeScript is this sort of static type checking, right? This compile time check that says, hey, you might have an issue here. There might be something you're doing here in your TypeScript code that is going to make it harder to maintain or read or utilize in the future. And so one example here is it's showing me that these parameters are being implicitly typed as the any type. Right, and we're going to talk about what the any type is. Any type stores, as you would expect, any type of value, right? But we want to probably be able to dig into and leverage, the actual specific typing to make sure we're taking advantage of TypeScript fully. And so it's going to indicate to us, hey, you've got the any type showing here. You might want to sort of fix that. Now, because this is an any type, and so we got a question here, I believe while it might be used for some organizations, integrating the transpiler into the browser could introduce extra load on the user. That's or a good point. Maybe it would make more sense to transpile directly to WebAssembly. That is another potential option. Great call out there, Roy. So with this, just what I want to show here is I can now, use a string. I can add a string in here, right? Because it's the any type. When I run this, I'm going to get concatenation instead of summation, right? But if I want to, in my JavaScript code, be more explicit, right, about what I'm trying to do and be cleaner in terms of my implementation and make it more readable, I can leverage type hints, right, to indicate that these values should actually be numbers, right? And so then if I attempt to pass in a string, then I'll get an red squiggly that says this, right? Argument of type string is not assignable to a parameter of type number. Now, we don't have that in JavaScript, right? But by leveraging this in TypeScript, we get that checking at compile time, and it helps us sort of indicate and know when we're going to potentially have issues, right? And so then we can come back here and say, okay, we're going to get rid of that. And now all of our red squigglies are gone, and our code should be clean. And when it gets transpiled into JavaScript, it should be clean as well. Okay, so the playground is one option we have for, leveraging TypeScript development, or maybe practicing, if you will, TypeScript development, checking out a particular concept. The other option we have is a full-featured IDE, like Visual Studio Code or Visual Studio. Visual Studio is very, very full-featured, right? It's a little heavier, sometimes a lot heavier than Visual Studio Code. To the question a little bit ago. So I think it is, definitely you have options when it comes to the IDE that you use. Visual Studio, you're going to leverage project types and templates that give you access to TypeScript conventions. You'll have you'll have IntelliSense relative to TypeScript. You'll have the TypeScript compiler directly integrated. All that stuff will be available to you with Visual Studio. With Visual Studio Code, TypeScript is supported natively. Now we're going to see here that we need to, have Visual Studio Code and then also have the TypeScript compiler or transpiler installed as well. And so we're going to look at that in just a sec here. So if you want to set up an environment using Visual Studio Code, I tell folks that, it's easy to just search for download VS Code, and you can kind of come to the link that you need for installing the IDE. And then The cool thing about Visual Studio Code as well is that it is supported on Windows, Mac OS, and Linux, right? Now with Visual Studio, we have that available within Mac as well. So that sort of opens that door and gives us those options also. But the cool thing about Visual Studio Code is that it, is supported cross-platform, as is TypeScript. So first thing we need to do is install the IDE. And then after we install the IDE, we install the transpiler. And the easiest way to install the transpiler is using Node.js. So if you don't have Node installed, you can similarly search for download Node.js. And we'll get to a spot that allows us to download and install a current version of Node.js, and with it, a current version of NPM, or Node Package Manager. And Node Package Manager is really what we would use, what we're going to use to install the TypeScript compiler. You can run this, and again, Node is cross-platform as well. So depending on your platform, there will be available options for you here. So if we take a look, let's sort of drill in. When we go to install, right, we can use npm, which is Node Package Manager, install, and then the name of the package that we want to install, in this case, TypeScript. If we want to install it globally across our entire system, we can use the -G flag, or we can omit the -G flag and install it local to a specific project, right? Once we run this and install it via npm, if we run tsc in our shell, we should see that we have access now to the TypeScript compiler. So let's take a quick look at what this how this goes. I'm going to be working within Windows Subsystem for Linux, specifically Ubuntu. If you haven't used Windows Subsystem for Linux, I think it's awesome. It allows you to run a distribution of Linux sort of natively within Windows 10. So I've got a Windows 10 machine here, but sort of on top of it, within it, I'm running separately this installation or distribution of Ubuntu. And so let me clear. Now this would work as well in the npm Node Package Manager works in your Windows command line. It works in Git Bash as well if you're on Windows. What I'm going to do here is if I type node --version, I'll see that I have Node installed. If I type npm --version, I have Node Package Manager installed. And then what I can do is I can type sudo, and I'll talk about sudo in just a sec, npm install -G TypeScript. Okay, so I'm using Node Package Manager to install the TypeScript package globally. That's what the -G is. And then because this is Linux, and because I'm going to be installing this globally and needing to make changes to sort of the underlying file system, I need to run this with elevated privileges. The way we run something with elevated privileges in Linux is with sudo, which stands for super user do. So by executing this command, it'll prompt me for my password. And then once I enter, that should install TypeScript. And the way we can verify that is by typing tsc. And we see here, this response indicates that we have TypeScript, or the TypeScript compiler, installed. Okay. So npm is the way we get access to that TypeScript compiler. Now let's look at compiling specific TypeScript files, or even a body of TypeScript files. Let's kind of look at that briefly here. So TypeScript files are going to have a .ts extension, and to transpile that TypeScript file, we use tsc and then give it the name of the .ts file, right? And that's going to result in a JavaScript or .js file, right? Multiple options available for how we can sort of manage the way the JavaScript gets generated. There are multiple configuration options that we have available to us. There's a whole list of them here. that we're not going to have time to dig into, obviously, because there, as you can see, is a really rich set of available options. But understand that these options can be utilized either on the command line, right, as you're working with a specific file, or they can be leveraged using sort of a folder or project level configuration file called tsconfig.json. Okay, so let's go ahead and keep rolling. Any questions as we're proceeding, please definitely leverage the chat. Here's a couple of compiler options that we can utilize. We're not going to be leveraging these, but when you kind of go back through this and have a chance to walk through the material again and look through the slides, kind of take a look at some of these. There are things that allow us to, for example, prevent the automatic implicit use of any, right? And so by leveraging these compiler options, we can, dictate how strict or loose we want that compile time checking to be, right? And that really helps in terms of building and then preparations for deployment. All right, so creating the TypeScript project. In VS Code, we can basically create a workspace, we can create project folders, we can create .ts files, right? We can use tsc-init to automatically generate that initial tsconfig file. And then, as I said, we can run tsc filename.ts to transpile a specific file. Or what we could do is, if we have that config file in place, we can run tsc without a file name argument, and it will go through our folder structure, find TypeScript files, and then transpile them according to the configuration options that we've set up in tsconfig. One example is we can, sort of specify a folder that we want the compiled JavaScript to land in, okay? Once we have that generated JavaScript, then it's JavaScript, right? So we can execute it the way we would any JavaScript. We can run it using Node, or we can embed it into an HTML page. Okay, Cheryl has a great question. Why would you install the transpiler only for specific projects rather than globally? In some cases, Cheryl, we're not, kind of the way I see that working out is you might have, or likely will have, a version installed globally, but if you have a compatibility issue with a given existing project, you might install a specific version local to that project so that you can have side-by-side versioning. That's one example. I think you're probably right. TSC or the transpiler is probably something that you're likely going to install globally, but great question. The option to install it locally is more a feature of NPM than it is of TypeScript, but great question. All right, so let's take a quick look at what this how this works. So let me clear my screen here. Let's see, we've got when refactoring existing JavaScript code base to TypeScript, is it valid in my point of view to do it gradually? And for example, adding any to types at first? Great point, right? And only later be more type specific. Or do you think an existing project should be refactored to be fully typed at once? And is any recommended in any other scenario? Excellent question. So I think depending on the size of the project, it's absolutely valid to do a gradual shift, right? A gradual move. Because if the project is really large, and we're going to say, hey, we can't, move to TypeScript until this entire thing is done, that might be, a little bit more restrictive than you want to be. So you're absolutely correct. Leveraging any as a type to sort of help you with that gradual move, I think, is very, very valid. The other place where any might come into play is if you are integrating with a third-party library that you don't have, or API or something that you don't have control over, then any might be something that you need to leverage to kind of manage, the looseness of the library you're integrating with, while still leveraging type check capabilities within TypeScript. We're also going to talk briefly here in a little bit about unknown, which also gives us access to, storing any type of data, but has some safety built into it. So we're going to talk about that in a bit. But great questions. Keep them coming. I love it. All right, so let's, I'm going to navigate to my standard repos location. I'm going to make a new folder called TS Reactor, and then I'm going to change directory to that folder. One of the things that you can do with Visual Studio Code is when you're in that folder, I can simply type code dot, and that will launch. Make this a little larger. That will launch me into this folder, right? So if I now build, I'm sorry, yeah, into that folder, that root folder. If I now add a new folder, if I call it samples, and I add to that folder a new sample1.ts, and I build out my same, sort of logic that I had before. Okay, so, same thing that we have here, it works. And then what we see here, though, is that type checking in place, right? That parameter X implicitly has in any type. If I make this number, and I make this number, and then I try and use a string here, I'm going to get that type checking, right? To indicate from a TypeScript perspective that we've violated the rules. Now, this can be transpiled to JavaScript, right? But what we're trying to do is bring cleanliness to our development at this level, right? In terms of our type checking. And by extension, this clean TypeScript will get transpiled into clean JavaScript. So it gives us that sort of added benefit. All right. So let me put this back. Everything's good. All my red squigglies are gone. What I can now do is if I navigate to that samples folder, I can do a tsc sample1.ts. And we'll see that it's going to generate a .js file or JavaScript file. Let me do this. We can see side by side, right? Just like we saw in the playground. Now it's complaining right now because it sees these two files at the same level and because it's both valid JavaScript, it's telling me that the add method is being duplicately defined, right? So that's kind of an interesting thing here. But the point is you can see sort of a way to transpile a given TypeScript file into JavaScript. Let me actually delete this. The other route that we can take is if I go up to the root level, and here at the root level, if I type tsc --init, we're going to automatically generate a tsconfig file. And you see all of the various options available. A lot of them, obviously. For example, we might say we want to target ES 2015. And then we might say that as the TypeScript gets compiled into or transpiled into JavaScript, where do we want that JavaScript to land, right? And so I can uncomment this line and say that I actually want it to land in the build folder. Let me save that. And then at the root, I could simply say tsc, no file, right? Hit enter. And then you see now I have this build folder with my sample1.js. So that's a way to sort of package that up from a deployment perspective. We had a question here, return type of a function is any by default? Yes. There is a void type. We'll talk about types here in just a bit. Excuse me. Now, the one thing I want to sort of just highlight here quickly before we move into specific information on types is we have JavaScript now, right? So we can simply run node build sample1.js, and it's going to run as expected, right? That's our console.log of adding 5 and 4, right? One thing we could do here is I can add a file here called index.html. Again, we haven't been referring as much to the individual parts of this. Definitely go back after the fact and, kind of walk through this again. But let me grab the index.html that's included here, just so I don't have to type it in the interest of time. And so I have, HTML, and within that HTML, I have a script reference to a particular JavaScript file. Right now, the one that's here expects it to be module 01. I'm going to change that to be sample 1. When I now navigate using WSL view, or however you might go about launching that index.html page, that's going to load up, right? Nothing interesting there, but if I hit F12 to go into my developer tools, you see there my 9, right? That JavaScript is being integrated into my HTML page, just like any JavaScript would, right? But the flow was TypeScript, type checking, static, compile time checking. And then once I had that clean, it generated clean JavaScript that we could leverage within, the way we do any other. Okay, so that's kind of the key, or what we're shooting for in terms of consideration. Pardon me. All right, so let's start to get into types. And I know, we're quickly running out of time, but I think it's important to sort of talk through this. When we declare variables within TypeScript, we can either use let or const, right? And let and const were added to give us block level declaration, which is very, very beneficial. Let is going to be, the keyword let with the variable name, colon, and the type we want it to have. Let allows us to either declare it and initialize it later, or declare and initialize at the same time. Const is the name of the const variable with a type. The difference with const is you need to initialize it at the time you declare it, because once initialized, it can't be changed. Okay, so you can leverage those just to sort of keep your code cleaner. But that's the mechanism we use for declaring variables within TypeScript. Let or const, we give it a name, we do colon, and then the type. Okay. Here are some of the types that are available, right? We have this any type, which we've kind of referred to already in some of the questions and discussion. Underneath that, right? And if you have experience, for example, similar to Pascal, right? Yeah. If you have any experience with something like C#, right, or Visual Basic.NET, a .NET, right, we have this object, system.object, which exists as the underlying type upon which all others are sort of based. Same kind of concept here, right? With any, we have primitive types, Boolean, number, string, etc. We have a void type if we need to indicate specifically that there is no return type from a function. There are object types, classes, interfaces. Again, next week, we're going to have a session on interfaces in TypeScript. Definitely welcome you to join us for that as well. And then we have this null and undefined that sit here. Now, we can't assign anything to null and undefined. Type, these are types, not values, right? We can't assign them those types, but TypeScript might leverage those internally to indicate that something is null or undefined. Okay. Enum, any, and unknown. Let's talk about this. So the enumeration type, right? If you have experience in other languages with enumerations give you the ability to create a grouped set of named constants, right? That are probably related, right? And so you have a name or symbol associated to that set of constants, along with a set of values assigned to that set of constants. And then you can use them as a unit. What you end up with is a new type. You can then declare variables of that type and leverage that enumeration, within your coding going forward. All right, they're created using the enum keyword. And again, it becomes a new type that you can use in variable declarations going forward. Gives you access to both the numeric value and the symbolic name. And really, they can be helpful in terms of improving code readability. So if we flip over here to the playground, not the playground, here's the playground. Let me clear this out. So if I type enum status, I have an open, a closed, and a danger, for example. You see here on the JavaScript side, which doesn't have this concept of enumerations, you see how the transpilation is executing to give us access to that feature. Okay, So what I could then do is I could declare a new variable of this status type. I could initialize it to status dot danger, for example, right? That's what enumerations give us, is that sort of multi-level symbolic naming. And then I can do a console.log of val. And then when I run this, we're going to see, let me clear this to sort of start fresh. When I run this, we see that we're logging the value 2. Why are we logging the value 2? Well, you can see here in the JavaScript that with an enumeration, numbering starts at 0 and then goes up by 1 from there automatically. So we have 0, 1, and 2. Danger is 2. When I output the value of this variable, it's going to show me 2. If I wanted to change that, I could start it at 1. You see everything then changes to 1, 2, and 3. You could also do, I want this to have the specific value of 2, and I want this to have the specific value of 8, right? And you see what happens here. When I run it, I get the results shown here, okay? Last thing is if you want, you can also do a console.log using the accessor, right? We can type status and then val in brackets, and that will give us access to the sort of named symbol as well, right? So we have access to both the numeric value and the named value as well. Okay, so that enumeration type in TypeScript can be very, very beneficial. Any, which we've been sort of talking about, right? It's a base type for all other types in TypeScript, right? It can represent any JavaScript value, so its name is very, very appropriate, right? And this can be useful when dynamic typing is still required, right? And a great example that was raised was if you're making that gradual shift, right, from JavaScript to TypeScript, the any type might be useful to help you ease into that, right? So wherever you can get more specific about your types, do so. But while you're making that transition, you can leverage the any type to still, you know, take advantage of the platform and move. Is there a performance degrade by using TypeScript? No, because TypeScript executes at compile time, right? So it's all at the compilation time. What you're going to end up with is JavaScript that is very, very compact and clean and is optimized for performance execution, either within Node or the browser. So great question. Really, though, the any type should be used sparingly. And by that, I mean should only be used for specific cases, right? Wherever you can, you should try to take advantage of the strong typing that is available within TypeScript as possible, right? Because that's why we have it. The unknown type is similar, where it can store values of any type. But the difference is that with the unknown type, we can utilize type guards and type assertions. And so with the unknown type, you're not able to, when something is, a variable is declared to be of the unknown type, if we assign it a value, we can assign it any value, but then if we try to access that value's properties, it's not going to work, right? With the unknown type, it says you can't access these properties until you make a decision about what type it should be, right? Are you allowed to use a string within Enum? That's a good question. I honestly don't know because I've not tried that. I'm usually just using, let's try that. Looks like it works, right? Now we're not going to get, so great question, Connor. We're not going to get the numeric. Now, a lot of times enumerations are used because we do need a set of integer values to go along with maybe the symbolic names, but it does support. Let's see what it does in the JavaScript. So because JavaScript is just sort of leveraging an array behind the scenes, right? It's able to accommodate that. So great question. With the unknown type, we're going to be forced to kind of specify or assert the type we expect to have before we're able to do something sort of with that. And so in the interest of time, I'm going to sort of start to drill into these areas here and kind of look at each one. The unknown type here. Let's look at this. So here's an example here, right? We have a variable called random value that is declared to be of the unknown type. And that can be initially assigned 10. It could then be assigned a Boolean, could be assigned a string. It's going through multiple iterations, right, of assignment. Because it is of the unknown type, it is valid to take on each of those different types of values. The difference is if we wanted to leverage some property of that variable, we would first have to use a type guard to check to see if it is of this particular type, and then we would use a type assertion to convert it. So if I take this in the playground, okay, if I were to flip these so that the last value assigned is of type Boolean, I could then add another type guard. Another type assertion. And then use that specific type accordingly, right? So, pardon me, if the last value assigned is a string, when I run this, I'm going to get the string. If the last value assigned is a Boolean, when I run this, I'm going to get the Boolean operation, right? Which in this case is false because it says if the random value as a Boolean, which is true, does that equal false? It does not, so we're going to end up with false. Okay. Pardon me. Okay. So that's the union type. I know we're kind of moving quickly through this, but definitely take advantage, leverage the slides, go back through the material again and kind of walk through it specifically. What happens if you don't use the type guards? Does it throw an error compile time? Yeah. If you try to access a property of that variable without doing a type assertion, then you're going to get an error, right? And so the type assertion needs a type guard to start to verify that what type we can convert it to and what type we're working with. So it gives you the benefit of the any type with the safety of, absolutely, great question, with the safety of making sure that you're explicit and specific about your intent. All right, let's talk quickly about union, intersection, and literal types. So coming back over here, the union type is interesting because what the union type supports is using a pipe, right? We can actually declare a variable to be able to accommodate multiple types. Here we're saying the variable multi-type can be either a number or a Boolean. So that then when we attempt to assign a number, that will be considered valid in TypeScript. If we attempt to assign a Boolean, that will be valid in TypeScript. But if we attempt to assign a string, that's going to be invalid, right? Because we've said this thing can have multiple types, but it can't just have any type. It can have one of these, right? So that's where unions come into play and can be very, very beneficial. And they're useful a lot of times, depending, again, on, you don't need type guards for unions. You can use type guards, but you don't need them. We can access this variable directly. It's just assigning a value has to adhere to the various types that it supports. And that can be useful when you have, like an API that you're integrating with that might have, again, a couple of different options available in terms of return values. Intersection types, which are a little bit more advanced, but we will just touch on them real quick. Intersection types leverage the ampersand and basically allow us to create a new type from two or more other types. All right, it's really a form of composition, So here the example, and it's often used with interfaces because interfaces, you know, might have multiple interfaces that you need to combine into a particular single type. Here's an example. We might have an interface called employee that has two properties. We might have a separate interface called manager that includes one property. If I want to combine these, right, I can use an intersection type, create a new type called management employee that represents the composition of the two. So that when I declare a variable of that new type, I now have access to all three properties, right? Employee ID, age, and stock plan. So intersection types can be useful in that respect, especially if you're trying to sort of compose multiple interfaces into a single interface type or a single type within TypeScript. And then the last sort of thing we'll talk about here are literal types. With literal types, a variable, a string value, right? If this test result was of type string, it could hold any string. If I create a literal type by declaring it as a specific type, right, and specify the string values it can hold, then I'm able to do what's called literal narrowing. That means if I attempt, so I declare a variable of that new type, if I try to assign the string incomplete, it will be valid. If I try to assign the string pass, it will be valid. If I try to assign the string fail, it would be valid. But in this case, I'm trying to assign it the string failure, which is going to be invalid, right? So it's a string that can hold, you know, multiple values, but we're sort of limiting it to the set of values that it can contain. And it works with strings and numbers, booleans as well. All right, a couple of more things to walk through, and then we'll need to actually wrap up. Last thing I want to touch on are arrays and tuples. So within TypeScript, we have access to arrays, right? Arrays are groups of sort of contiguously located types of information, right, that we use as a group. So we might have a list of numbers. To declare an array, we use number and then square brackets, and then we can assign 1, 2, and 3 and access these elements by their index, which is going to be 0 based. The other way that you can declare an array is with the array keyword and the number or the type as a generic. These are equivalent, and there's really no benefit of one over the other, but you might see both in the TypeScript code that you review. And then finally, tuples. Tuples are like a type of array in that it can store multiple values, but tuples give you the ability to store multiple values of different types. Okay, so in this particular case, person 1 can store a string and a number as a collection, as a group. And when we use or initialize that tuple, we need to use values in exactly the same order of those types, right? I need to do Marcia and 35. If I try to do 35 comma Marcia, it's going to give me an error because the expected sort of sequence is string first, then number. Additionally, if I tried to add Marcia 35 and then a new sort of Boolean here, that's going to complain as well because the tuple expects there to be two values in this collection. The first one's a string, the second one's a number. So hopefully, and I know we did kind of a whirlwind at the end there, right? But hopefully what you see is there's a lot of rich feature available within TypeScript relative to available types and different sort of mechanisms we can use within our code to really improve the developer experience when it comes to JavaScript development. And then once that TypeScript code is clean, leverage the transpiler to generate clean JavaScript that we can utilize the same way we utilize any JavaScript. So what I would like to now basically do is I'm going to see if there are any additional questions. Again, this set of slides are available. If you checked in, let me go down here to here. Oops. Go all the way down here. If you would please, we review inheritance in the future. Yeah, Hussam, so a couple things. Hussam, thanks for posting the YouTube channel. The check-in link here is the survey link. Please use 13089. This is your opportunity to provide feedback to us about these sessions, about the types of things you like to see. Definitely encourage you to fill out that survey. And Yair's question, will we review inheritance in the future? We might have a chance to do that. Come to the interface topic next week, because we're going to have a chance to kind of drill in a little bit to that as well. I'm going to just sort of hang out for a bit, for a minute or two here. If there are, you're welcome, Cheryl. Thanks for being here. It's great to have you here. If you have any more questions, definitely please feel free to post those into the chat, or as Hussam said, if you prefer to speak those questions, we can do that as well. But I just want to make sure you have a chance, if there are any final questions, that you have a chance to ask those. And then hopefully we'll see the rest of you next week. And for me, it was just a true pleasure being here with you. I really appreciate the opportunity. So any questions, feel free to post those. Otherwise, you're free to go and have an excellent day.
All right, as we mentioned earlier, the session is recorded and it will be available later on our YouTube channel. So if you happen to join a bit late or you missed any part, you will find it on our YouTube channel. And the check-in link will still be working for some time as well. It has all the resources and links in one place, including the slides of today. So use that. I included the link in the chat, and I will also include it in the video description so that you have access to all these resources.
Excellent. All right, folks. Have a great day.
Have a great day, everyone.
We did have
thank you, Alan, for today.
Yep.
Is it possible to debug? Yeah, there's a question.
Yes. Well, it is, because what you're going to be doing is actually debugging the resulting JavaScript that gets transpiled from the TypeScript. So great question. You can debug it. Now, Visual Studio Code has integrated debugging, which is kind of useful as well, so that as you're executing that, you can debug that as well. But yeah, great, everybody. Thanks much. Pleasure being with you. Have an excellent day.